Hello, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. We'll begin in just a moment, but first I need to conduct a little bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Let's see here. Do I see hands? Thank you. I see hands. You guys are great. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. And in addition, a recording of this webinar and the slides will be made available to everyone within 48 hours. So if you have an emergency and you need to drop off, I will send you a link to the recording as well as the slides. So don't worry about that. I would like to introduce you to today's speaker. It's Akmal Chaudhry, and he is GridGain Systems technical evangelist. He goes all over the world talking about Apache Ignite, and he's going to be presenting today, Improving Apache Spark in In-Memory Computing with Apache Ignite. And with that said, I will turn the floor over to Akmal. Go ahead. You have the floor.
Thank you very much, Alicia. Thank you very much for everyone that has joined. Appreciate, your time is valuable, and hopefully the session today will be helpful to you. And good morning, good afternoon, good evening, wherever you are joining from in the world. I happen to be in London, so it's just gone 7 p.m. for me. So after the webinar, I've got some other things to do, mainly get dinner. But thank you again. Appreciate all of you joining today. So without further ado, let me just switch to presentation mode. Okay, so Apache Ignite then. So as Alicia mentioned, so I work for GridGain Systems, and actually I've been with the company almost 1 year now. And my role is to help raise awareness of Apache Ignite, principally the open source technology, as you may be aware of. GridGain has some commercial offerings as well, but generally I tend to focus on the open source only. And as Alicia mentioned, lots of travel in terms of meetups and conferences to really undertake this mission of trying to get the word out, get more people interested in this technology, to download it, to use it, to try it out. And we've had some great success this past year. And so initially, when I joined the company, I knew nothing about in-memory data grids. I didn't know anything about Apache Ignite. And so over time, I've learned a lot this past year. And initially, when I joined, my boss asked me, why don't you blog and write about your experiences, what you have learned, and share this with other people in the hope that, if they are just beginning this journey as well, they will have a chance to learn from your experiences. And so if you're interested, then just search on my name at dzone. You're welcome to look on the GridGain blog website as well, where the blogs appear initially. But I've been writing some articles during this past year, initially very basic sort of content, but over time it's become much more technical, and we've started to look at things a lot deeper, especially this year. So this particular topic is an interesting one because obviously Apache Spark is a very popular technology, but we believe that Ignite offers some great capabilities for Spark users, and this kind of integration of these two technologies is really going to be useful for, I think, a lot of use cases. Okay. So in terms of Ignite then, a memory-centric distributed database caching and processing platform, and then for transactional, analytical, and streaming workloads, delivering in-memory speeds at petabyte scale. So a couple of key points there. As you can see, the bold for database caching and processing. So historically, where Ignite has come from is as an in-memory data grid. Now, an in-memory data grid is far more than just caching. So it's additional capabilities as well, sort of processing, transactional. It does, compute, streaming. There's a whole range of these components that constitute Ignite, and they work well together. It's a case of the whole is greater than the sum of the parts. Transactional, well, historically, if you look at things like relational database systems, for example, and long time ago, before that, we had Codacell and network database systems used for a lot of banking type applications where transactions were very sort of prevalent. That's still the case today, of course, but increasingly we see this shift towards analytical and streaming workloads, we want to be able to run analytics on data. We want to be able to use various APIs. And streaming data, things like sensors, wearables, IoT type of devices, as this data is arriving, we want to be able to process that. So Ignite can handle all of these diverse and different types of workloads and do them very well. Delivering in-memory speeds at petabyte scale. So in-memory is what Ignite has historically, again, done very well as the way to scale and improve performance for applications. But equally, there is sort of database capability that's been added, particularly this past year or so, this sort of persistence, which we'll talk about in a few moments' time. All right, so the big picture, if you like, this is a nice kind of summary. So at its core, we can see this memory-centric storage, which I sort of alluded to just a few moments ago. If we look in the bottom right, then we've got this third-party persistence. So Ignite can work very well with a lot of third-party persistence. And here, particularly if you've got transactional systems such as relational systems, then Ignite can cache the data, and it can keep that cache and the relational system in sync. Okay, this is a very useful property, and there are use cases where this is very helpful. Personally, when I've presented at a number of meetups this past year, for example, some people have come up to me at the end to say, well, look, we use this particular relational database system. It might be open source or it might be commercial. In the whole, for various business reasons, they need to keep that. But there are some cases where performance could be improved, and Ignite has really helped them to push those boundaries and get improved performance from their system, certain types of queries that it can manage really well. Equally, there's integration with HDFS and NoSQL as well, and we have a bunch of blog posts and white papers in this space as well. And so if you're working with existing technology, which tends to be the case in a lot of businesses today, there is business value there. These systems have been developed over time. Resources, money, effort have gone into these things, and they have to continue to be enhanced and used. And therefore, Ignite can really add value in that space. Now, if we look in the bottom left, then it says Ignite native persistence. So this is a new feature that was added last year. So the idea here is that over time, particularly if you're working with a lot of in-memory data, yes, in theory, you can continue to add memory, and memory, of course, is much cheaper today than it was in the past, but it may not be possible to cache all of the data. And so this ability to store data and then page in what you need as you need it becomes far more useful. And I think particularly when people talk about big data, and big data being vast quantities of data, and these idea of sort of data lakes and all of these kind of things, where the quantities of data are just huge. Perhaps we don't need to process all of that all of the time, and we don't need to cache all of it all of the time. We need to persist it, use what we need, and then the rest of it can remain in sort of persistent storage. So this is a very useful feature as well. Above, we can see a number of sort of interfaces and components. So SQL. So SQL, it's very, very popular language still today. The level of support that Ignite provides is SQL 99. And one of the benefits, of course, is that you get skilled developers who are familiar with the language, and there are lots of business intelligence tools that integrate with this as well and use it. And it's kind of intergalactic data speak. I mean, that's the real important thing. It's very prevalent. It's still widely used. It's extremely powerful, and especially when you're using it for a lot of in-memory operations, I mean, you'll get phenomenal performance with technologies such as Ignite. Key value, historically, again, this is where Ignite has come from in terms of in-memory data grid. Now, the value, of course, can be anything, okay? So it could be simple types, such as string, character, floating point, but it could be user-defined types as well, and complex types. So it could be a financial instrument, for example, or it could be a healthcare record. and these can be defined, by developers as your business requirements require these sort of objects and entities to be modeled. Transactions, very important. So I talked about this very briefly a few moments ago. The key thing here is that Ignite supports both locking, pessimistic transactions, and lock-free, optimistic transactions. And these could be relevant for different use cases. The key thing here is that transactions are particularly if we're talking about locking data, and then we want this notion of consistency, the system moves from one consistent state to another consistent state. This is very important, and particularly in many domains such as the financial world, for example, where they deal with billions and trillions of dollars on a daily basis. It's very important to resolve these and to ensure that these commits happen and that the system moves from one consistent state to another. Now, I can my personal experience this past couple of months, for example, I know how valuable this notion of using transactions is. So I'm a great fan of these massive open online courses. There's a website that I particularly like. I won't mention them, but I decided there's a course that I would like to pay for, and I would like to get the certificate for this. So filling in the various details, putting in my credit card numbers, and I hit the submit button, and it comes up with a message saying there is an error. Go and talk to the support desk. Well, I didn't think anything too much of it. These things happen. Sometime later, I happened to look on my credit card statement, and I noticed that I've actually been billed. But on the website itself for this course provider, there's no information. Now, I contacted them, and they said, we have no details. That transaction never took place. The bank has charged me, and unfortunately, I'm kind of stuck in the middle. So there's an example of a poorly designed system, in my opinion. Okay, so this shouldn't happen. This scenario shouldn't happen. And equally, if we are transferring funds from one account to another account, we cannot have a situation that the funds leave one account but are not credited to the other account. This is not allowed. So the value of transactions would help us ensure that the system moves from one consistent state to another consistent state. Very valuable. Equally, there are other scenarios if we think about things like computer-aided design, for example, or computer-aided manufacturing, where typically a designer, he or she will download part of a design onto their local workstation. They will work on that part and then check that back into some central repository. The chances of conflict there are far reduced, and much more remote. And therefore, we can go for the lock-free type of environment in that case, where we are reasonably confident that any changes that we apply will be fine, and we won't have a conflict with somebody else. So very, very useful sort of capabilities there. And again, historically, where Ignite has come from, these capabilities have been there for quite some time. Compute services, won't say too much about those. They've been covered quite well in other webinars. Streaming, very briefly. So if you are working with some streaming technologies, say Flink, or Spark streaming, then again, there is great integration with Ignite. So Ignite doesn't provide its own streaming engine, not necessary. Okay? There are great streaming engines already on the market, but it can integrate, and through adapters and connectors, it can work with these just fine. Lastly, machine learning. I will have a brief slide at the end of this presentation where I'll say a few things about that, kind of a bonus slide, and a few words to add to that. But essentially, the concepts around machine learning, as many of you will know, have been around for a very long time. The problem, I think, has always been not enough compute power. Now, with the advent of cluster computing technologies such as in-memory data grids, of which Ignite is a great example, this allows a lot of these algorithms to be parallelized, divide and conquer, share the workload amongst the cluster nodes. They can do some small part of this, and therefore there's a great way to evaluate, get data back, get information back, make business decisions much faster. And of course, as many of you know today, time is money. The world is moving very rapidly, where it's very important that where there are opportunities, where there are threats, business decisions have to be taken very much faster than they were ever in the past. Okay, and so the idea that now you can make decisions sort of minutes and hours versus days and weeks really is very helpful for a lot of business cases, I think. Okay, other things, so lots of verticals: financial services, telco, travel, logistics, e-commerce, pharma, and healthcare, IoT. In fact, I did a healthcare webinar late last year and wrote a couple of blog posts on this area as well. Would encourage you to investigate these further through various white papers and blog posts that we have on the website. Okay, so let's drill down a little bit further then and talk specifically about Spark and Ignite. And so sometimes I'm approached by people at meetups and conferences, and they're kind of a little bit confused because they see some similar sort of capabilities with Spark and Ignite, and they kind of feel that these are very similar technologies. Well, the thing is that these technologies complement each other, and they are good for different types of problems. And Ignite can work very well with Spark. It's a distributed memory-centric database. It supports a range of capabilities, which we've talked about already: transactions, key value, SQL processing, machine learning as well. Now, of course, some of these Spark can do as well, but there's additional capabilities as well. And the working with a variety of different types of workloads too. Spark is great for streaming and computation. Okay, so it's a great compute engine, does things very well in memory. And then historically, again, if you look at the origins of Spark, very much designed as a better way to process data than Hadoop did, which typically used to have stages where it would write things back to disk, and then things were very slow. I mean, what Spark did was to keep a lot of the data in memory so it wouldn't have to write to disk. But again, typically for a lot of use cases, MapReduce type payloads, OLAP. So there are differences, some similarities as well. I mean, Spark supports machine learning libraries as well. I mean, Ignite does too, but I'll discuss that a little bit later on and hopefully make it a bit clearer for you as to where we kind of sit in that space. Okay, so Ignite and Spark together. So this notion that these two technologies are complementary, then it becomes much easier then to really quantify or present a sort of a case as to why you would want to use these together. And so Ignite can be a memory-centric store for Spark. And again, because of its caching capabilities, its in-memory data grid capabilities, it's very strong in that space, but equally with the persistence we talked about a little bit earlier on, again, there's the ability to handle vast quantities of data and manage that data really well. Now, because of this kind of tight integration between Ignite and Spark, so things like query execution, for example, avoids a lot of data movement. There is considerable engineering effort that has gone in from GridGain, and this really helps a lot in terms of avoiding data movement. I mean, that's the key thing. So Spark just becomes another API as far as Ignite is concerned. Data frames, SQL performance. Okay, we'll look at data frames a little bit later on and show you how that integration is can be done. But again, similarly with the SQL, Ignite can do indexing on data. I believe Spark still cannot. So there again, you can get enormous performance boosts because of this capability. One of the nice things that Ignite has had for some time is this notion of a sort of shared RDD. So this ability to share state and data amongst Spark jobs, and again, for jobs that sort of terminate, beyond the lifetime of the process that created some data, we can access that data using this data structure, this shared RDD. Faster data and streaming analytics, obviously, because of this tight integration, it means that things like affinity, co-location, local processing, all of these things can be done much, much faster. And these information about partitioning can be passed by Ignite to Spark, and that will help, again, significantly in terms of boosting performance. Okay, so in a kind of a graphic way, this is a nice representation that shows some of the things that we've just discussed over the last couple of slides. So here we can see an example of this in-memory shared RDD or data frame spans a number of these nodes, as you can see. Now it says there GridGain node equally. It could be an Ignite node. That's fine. I mean, it's just a simple sort of labeling there. And just to summarize then, share state and data among Spark jobs. I'll show you a demo that illustrates this in a couple of minutes. No data movement, in-place query execution, which we mentioned just a few moments ago, boost data frame and SQL performance, and SQL on top of RDD. So Ignite has had some level of SQL support for quite a while, but really significant effort gone in last year, well, from last year to today, where the trying to get SQL 99 support, and that is really available now. I think you'll be able to browse and have a look at the website for information on that. As far as I'm aware, it's pretty much supported. If there are things missing, I think they will be documented, but the goal is to have full SQL 99 support as of Q2, Q3. The other nice thing is that, of course, with the key value interface, of course, that's transactional. Whilst the SQL was being developed from last year, then that was in memory only. But again, adding transactional support to that is a goal for Q2, Q3 this year. Okay, so let's have a look at the what options do we have available? So in terms of how can we deploy this? So typically then in this scenario, we've got Ignite deployed in separate cluster, which I think is preferred. So you can do this two ways. You can do this either in sort of embedded mode, or you can run it as a separate process. And I think the separate process is the preferred option these days. The embedded mode is being deprecated and will go away at some point. And the demo that I'll show in a couple of minutes' time will again show you how we can do this and make good use of storing state in this shared data structure, and then be able to access it using another application. So more on that very shortly. So this shared RDD is just an RDD abstraction. So from the Spark side, Spark just sees it as an RDD. And then from the Ignite side, Ignite just sees it as a cache. Now, it has to be mutable, okay? So if you've worked with Spark, you know that RDDs are immutable. But with this particular implementation, because we need to have this capability to read and write, then of course, being an Ignite cache and what Ignite sees it as a cache, then it has to be mutable. And this has certain value. Again, you'll see that very shortly in the demo that I'll show you. Again, just touching on this issue of being able to run SQL on top of this, if we need to do that, very useful, and again, very powerful in terms of the types of queries that we could run. And similarly, this ability for sort of indexes and in-place execution, which I mentioned a few moments ago. So Spark does not support indexes. Ignite supports indexes, okay, that can act as a great performance boost. But again, because of the tight integration as far as the SQL is concerned, the ability to run in-place execution of SQL queries without having to shift a lot of data around or no data around, as the case may be, then that again gives you, significant benefits as far as the integration is concerned. Okay, so here's a kind of a simple example illustrating how we can do this write and read from the Ignite side. So there's a little bit of Scala code there. Not very complex, but we have this notion of a Spark context and an Ignite context. Again, I'll show you the relevant documentation that you can have a look at. It's very straightforward, and the demo will illustrate this very shortly. So here, all we're doing is the top code on the right-hand side is we've got this shared RDD data structure, and then we are simply 10 parallel operations storing this list of 1 to 100,000 integers directly in this data structure. And then just below it, again, what we're simply doing is getting a handle on this shared RDD. This could be in a separate program. That's the way that I've implemented it in sort of the particular demo that I'll show you. And straight away, we can do some filtering upon this and then simply look for values greater than 50,000 as this example illustrates. Okay, and this is directly taken from the little bit of code that I wrote. So all I did was write a couple of very small Scala programs, just to use Maven to package them up into a jar file. And then this reader and writer program, I can just call from the command line to illustrate the point that how we can write to this shared structure. We can read back from this shared data structure as well. And you'll get to see that in a couple of minutes. Okay, so let me just describe the particular setup that I want to show you then. Okay, so I will drop out of the slides in just a moment. So what I've got then, I'll have a couple of terminal windows, and I'm going to fire up a Spark master, one Spark worker. Now, there's a limit to what I can do, obviously, because my laptop has only a certain amount of resources available. That's why we keep it sort of fairly low. I'll fire up an Ignite server node as well. And then I've got, as I mentioned, in this particular jar file, I've written these couple of short programs just to write to this shared RDD and then read from it. And we've got this RDD writer, RDD reader program. Subsequently, what I'll do then is once the data have been written into this data structure, I will kill Spark. Okay, so I will shut down the worker, and I will gracefully shut down the master as well. And then we'll switch to the IDE, where I've actually got some code written in Java, which will connect to this shared RDD structure and then read back the data from there. So what I'm trying to show you there is that we can run this from a variety of different environments, whether it's from the terminal or within an IDD, and the language doesn't matter. So it just so happens that I wrote the RDD writer and RDD reader in Scala, and then within the IDE, I have some Java code which just pulls data back out of this. And again, this could be very useful because often in a lot of business environments, it isn't necessarily the case that we adopt just one particular language or one particular framework. And one of the nice things about Ignite is that although it's a Java-based technology and obviously supports Java, and in this case, we've got some Scala code working as well, but equally, there is excellent .NET and C++ support as well. And some environments in large organizations, different teams may be working with some of these additional frameworks and languages, and therefore this provides the capability to share the state amongst these. And of course, if you're working with other languages as well that don't receive the sort of level of support that Java, .NET, and C++ do at the moment, then there is obviously things like ODBC and JDBC you can use as well. Okay, so let me just drop out of here then and just minimize this for a moment. Okay, now I've got a couple of terminal windows open here, and I did check this a little bit earlier on with Alicia, so hopefully I'm zooming in here, so I hope you'll be able to see that without too much difficulty, and you'll actually get something that is visible to you. So in this window, I'm just going to fire up Spark Master. Okay, so I've got Spark installed here. I set the Spark home variable, so that's fine. That's up and running. And then just below here, what we'll do is we'll start a worker. And in this case, I've disabled the logging. Otherwise, there's too much output on the screen. Okay, so let me just minimize that down for a moment and then just switch to the browser. Okay, and we should be able to, if I just refresh this. Okay, so that's fine. It tells us that Spark Master is running, and then we can just check on the state of the worker. So that's all in good. Okay, so everything looks solid there. Great. All right. Next, let's again zoom in on this side. And what I'm going to do over here is I'm going to fire up an Ignite node. Again, I've set my Ignite home variable here. And notice here that I'm using a configuration file, which is provided with the standard distribution. Example shared RDD. Okay, so this is a file that can be used to set up this shared RDD. And of course, you can have a look at this and customize it to your own requirements. And so we'll just start that up. Okay, it just takes a moment or two. Let me just minimize this a little bit, get a bit more space here. Okay, so that looks healthy. So it's telling us that there's one server up and running. That's fine. Now, one of the things that we can do with Ignite is there is a web console that we can use to have a look at how things are running, CPU usage, what caches are available. And in order to do this, there is a web agent that we need to run. Okay, so if I launch this, it tells us that indeed there is a cluster with one node. Okay. Okay, there we go. So, oops, there we go. Just pull that back. And if we go over here and have a look at the console, and we can switch to monitoring. Just give that a moment to refresh. So there we go. It tells us a little bit of information. Not very useful at this point in time because we've only got one node running, not a sort of large cluster where it would probably be far more useful to us. And if we look a little bit further down, we can see indeed there is this shared RDD here we are, which has been created. And we can just get a little bit of information on this. There we are. It tells us it's partitioned and sort of various other information here, which we don't really need to drill down into today, but that's fine. And at the moment, we've got no entries here. If we look on the right-hand side, backup is 0, primary is 0, total is 0. That's fine, okay? So we'll just minimize this for a moment. Now what we'll do is we will run this RDD writer. Just give that a moment. And it will create this list of 100,000 integers and store them in this shared data structure. Now, notice the window a little bit above there to, oops. Okay, I think this small problem there. Let me see what the issue is. Okay, there we go. Sorry about that. I think that's my fault. Okay, and now if we run the reader, okay, there we go. Right. Just give that a moment or two. It should finish momentarily. Okay, there we go. So it's output this particular value. The count is 50,000. So it was a simple filter just to pick out how many values were greater than 50,000. Well, it's 50,000. And if we switch back and have a look at the console, here we can see now, so the total is 100K, primary 100K. There's no backups created. We didn't specify that. So that's what's currently stored in this shared data structure. Okay, so what I can do is here, I will shut down the worker and then just stop the Spark master cleanly. Let's just do that. Okay, and we can switch to the IDE now. So this is using some code that was provided as part of the distribution that comes with Apache Ignite. There's a whole bunch of examples available here. So there is this shared RDD example that's written in Java as well. So all I've simply done here is really commented out a couple of lines which would normally create that list anyway. Since it already exists in this shared data structure, we don't need to create that list, but I would like to read it back. And so I can run this now from here. go. It's a little bit of logging information that comes up. Just make this a bit bigger. Okay, now there's the list coming out in the console window. This takes a moment or two. Meantime, if we switch back over here, okay, now what's happening here, can you see that because of some configuration within this particular code, I've got some backups being created. Okay, so now it's up to 200K, and the primary is 100K, and the backup is 100K, and the data are being read back here as well. Okay, this should finish in just a moment. Okay, if we go down, there we go. And this code also runs a little bit of SQL. So if we look closely here, we can see that there is this table that's created. Okay, and if we drill down into the code itself, we can see here sort of the SQL. So it's looking for values greater than 9 and less than 100, and then just limiting it to 10, which is exactly what was output on the console. Okay, so we can stop this. Let me stop this. Okay, now we'll lose our connection over here. That's okay. We'll come back to that in a moment. And let's switch back to the slides. There we go. Okay, so data frame support. So the RDDB support has been there for quite some time. The data frame support has been added more recently, and I think it's something that people have been waiting for. So again, optimizing Spark's Catalyst engine. We talked about in-place execution on the Ignite side. No data movement, very useful. What we want to achieve in a distributed environment, because we want to really run things where they are, bring the processing to the code, to the data, rather than the other way around, the data to the code. And also for a lot of the scenarios, this works really well. There are things like affinity, co-location information, partitioning information that Ignite can provide to Spark, which really helps speed this process up significantly. One of the benefits that we can see is, here's an example where we have a query in SQL, for example, and the fact that data happen to be co-located, in this case, we've got cities and countries, and co-location has been done with all the cities that are associated with a particular country. It makes life a lot easier because, again, that stops data movement. If we didn't have this co-location, there would be data movement between these nodes. The query would still work, but then the problem is that performance would be affected. It would be a lot slower. All right, so how to work with data frames. So storing data and then retrieving it, similarly as we did previously with the shared RDD. So it's very, very straightforward. And again, we've got a couple of examples that I'll show you. Creating a Spark session, we need a configuration path to a file. And in this case, on the code on the right-hand side, for example, you can see that what it's trying to illustrate is that we want to create a data frame from a JSON file. And again, I'll show you the code for that in just a moment. Once we've got the data, then, as the data frame exists, and we want to save that into Ignite, then what options do we have available? Well, there's a couple of possibilities then. So we can append it, okay? So if it already exists, we just add that to the end. We can override. So if it exists, we delete the old one and we create a new table. Error if exists, okay? So this is useful, catches an exception. We may want to handle the situation where we don't want existing tables to be affected. And of course, we have an option as well, but we simply ignore it. Okay, so we don't raise an exception, but we simply ignore what the operation is trying to do. And again, this is well documented on the website. So reading from data frames here, again, following the standard approach that's actually defined very well for Spark. We've got some Ignite specific things here, so we need to define the data source, what is the table we want to read, and then if there is some configuration information as well, we need to pass that in. And then once that's done, it's very easy. Again, we can simply run SQL code. Here's an example that we're doing a select statement from a particular table, and we're qualifying that with a where to narrow down what data we are actually searching for. There's other ways that we can do this, and in the demo code, I'll show you an example of an alternative approach to this. Okay, so in terms of the data frames demo, then, so what have we got then? So this is an Ignite server node, okay, and I'll run this directly from the IDE. So this is to simulate a kind of a sensor, a stream of data that's arriving. So we've got a sensor data generator, writes random data to a socket, and then a stream application that connects to this socket takes that data. Imagine that this is sensor data coming from sensors or wearables, something like this, for example, and then it streams it by Spark. As it arrives, creates a data frame for that, and that's what actually gets saved into Ignite. Okay, and again, I'll show you where you can download the code and have a look at this for yourselves. And then finally, of course, that's great. You know, we've got the data in, but then we actually need to do some querying. So how do we do that? Well, we simply have a query application that takes the data from the table and does some manipulation of that and does some summarization from that. And again, code is very, very, very straightforward. And then because we are working with data frames, it's far cleaner as well. There's a few things like having to create tables, which we no longer need to do, because simply we can do this from the direct support that we have for data frames. Okay, so let me switch back out again, and we will go to the IDE. Okay, and I just need to switch projects. So let me close this one. And here's the data frames one. Okay, so first thing we'll do then is we will start up an Ignite node. And we can do this directly from within the IDE, excuse me. Okay, just move that up a little bit. There we go. And if we just look down here, we notice that now, of course, here, it's picked up the fact that we've got something running, which is useful again, because if we go back to the web console and have a look at the moment, well, it hasn't connected here. Let me just try refreshing this. Okay, go here and then go back, and then go back to the dashboard. Okay, so there we go. So at the moment, it's all clean. There we go. And once we've created a couple of these tables, we'll come back to that. Okay, so next thing to do, let's launch our sensor generator. Okay, so there we go. Sensor sample generator is up and running. You're probably underwhelmed. It doesn't actually tell us anything more beyond that, but again, the code is fully available. You can have a look at this in your own time. So it's just generating some data for us, writing to a particular socket. Now, at the moment, nothing is reading that data, so it's kind of just disappearing. But we'll take care of that. Okay, so the next thing to do then is to create the stream. Okay. All right, and we'll get quite a lot of info messages coming out here. And again, I haven't configured my logging for this at the moment, although I did do in the terminal environment. So there's a lot of info messages being put out here. That's okay, that's fine. It's up and running, it's the main thing. And then finally, if we do the query, okay, again, this just takes a moment or two to start up. Again, there's a fair bit of logging information coming out. Okay, just give that a moment or two to get up and running. All right, there we go. So as you can see, let me just make this a little bit bigger here. So there it's outputting to the console a table periodically, as you can see, and it's just showing the top 20 rows. And this will just loop forever. And it's got sensor ID and the count. And as that data builds up, so does that table. And if we switch back and have a look over here, you'll notice now that we've got two caches. One of them is this one, okay, which is sensors. And the other one, which is kind of growing, as you can see here, is the total and the primary, both these numbers going up. And if we click on here and have a look at this, okay, so this is simulating sort of temperature data that's coming in. Oh, there we go. Okay. And I'll show you where you can get the code for that in just a moment. Okay, so let's switch back to the slides. We're almost done. Okay, just 2 or 3 more left. All right, so bonus. Okay, so I mentioned this machine learning grid a little bit earlier on. So the key thing here is that integration between Spark and Ignite, I mean, it requires quite a lot of engineering effort. And therefore, trying to integrate something like machine learning also, you know, that would require a lot of engineering effort. At the moment, as far as the machine learning is concerned, our customers and the GridGain customers, I think, are very happy with the level of support that's provided in terms of the machine learning capabilities. And this is really useful for those situations where in the past data typically resided in Ignite. People wanted to run machine learning algorithms on that data, but it was quite painful because you had to do ETL. And when you've got large quantities of data, that doesn't work very well. I mean, it's really a non-starter. So having this capability, supporting these algorithms, k-means, regression, decision trees, so on, there's a lot of flexibility in terms of what you can do. So if we look at that IoT example I just showed you a moment ago in terms of the code, so imagine we defined a window across that data. Suppose we were interested in, say, the last 10 minutes of data, or let's say we're interested in sort of 50 events or something. As that arrived, we could run some analytics on that, maybe run some SQL in memory. We can do that. It would be very fast. Or we could equally, once that's done, perhaps we could apply some machine learning capabilities to that. And on the Ignite side, that's very easy to do as well then. Again, using the power of a cluster, help us make some decisions and give us the results much, much faster. Multiple language support. So obviously there is a move to try to support some of these popular data science type languages, things like Python and R, but initially obviously Java, C++, .NET, these would be, you know, the top level support that would be received. The other key thing here is that these algorithms that have been implemented from scratch to take advantage of distributed capabilities, distributed processing. So you have the options to run things locally if you want to. That will work on a single node. Or if you really want to use the power of the cluster, you can do that as well and run these algorithms in a distributed fashion. And the examples that are provided as part of the download with Ignite give you those capabilities and those options. And they're, you know, very well implemented at the moment. And there are examples will show you how you can address certain types of problems. All right, so very briefly then, so we're almost out of time. Let me just summarize a couple of things for you then. Okay, so here's the homepage for Ignite, ignite.apache.org. In the top right where it says screencasts, this contains a couple of very useful screencasts at the bottom here. Ignite Web Console, automatic RDMS integration. I mentioned this earlier on, right at the beginning of the presentation. 10 minutes of your time and you'll get to see how easy this is, how the code is auto-generated. You get a project, you can just load it into your IDE, and all you need to do is add your credentials, the IP address, and the port number where your relational server, for example, reside. I think the example uses MySQL, and again shows you that this consistency across both the relational system and the cache, and that if there are changes in either, those are reflected correctly. Okay, and it keeps the system perfectly synced. As far as more information on the RDDs and data frames, there's a little bit of documentation on the home page here, but a better place to go is the readme.io docs, where you'll see a lot more information in terms of the integration, and it goes down into a little bit more detail using both Java and Scala examples, and providing a lot more than I've been able to cover today. Finally, I did say that I would tell you where you can get the code for the Ignite Spark IoT. So my colleague Val Kulichenko, he has very kindly written this version based on an earlier version by my colleague Dennis Magda. So if you go to github.com, okay, and just here we can search for Val. One of the projects that he has is this Ignite Spark IoT. And the nice thing here is that the version actually contains two different implementations. So there is a data frames implementation, and there is the older version which uses RDDs as well. So you actually have an opportunity to look at both. And if I just switch back to the IDE for just a moment, let me shut this down and shut this down and shut this down. Okay, that's done, and shut this down. Okay, just close this a moment. So here, what Val has done then is this query stream. All of this code uses the data frames approach, as you can see here. You know, we looked at similar sort of code in the slides, but equally, you have the opportunity to have a look at the earlier version here as well. There is sort of implementation which you can review. And again, notice here, for example, the SQL statement. So very good SQL integration. Again, great data frame support now. And I think finally, just let me just close this. And one last thing which I can show you and take some questions. Okay, so this is the latest version of Ignite 2.4. I think 2.5 is almost sort of imminent in terms of release. So as I mentioned briefly, so machine learning, so there's lots of examples of code. Some of these, as you can see, prefixed local example, it says here. Let me just zoom in there. And then there's also a distributed example, and K nearest neighbor, regression trees, decision trees, all of these capabilities shown. As far as the data frames examples go, there is Scala implementation. Again, these can show you how data frames work with Ignite from Scala. The Java code will be available as part of the next release. Okay, this is just a minor thing that was omitted in the previous release, but it will be included in the next one. Okay, and I think with that, I am done. So just go back here then, and okay, so we've got about 5 minutes or so. So happy to take any questions. I'll do my very best to answer them. If I can't answer them, then I'm happy to follow up, and you know, please feel free to drop me an email. So it's just first name dot last name at gridgain.com. So it's just akmal.chowdhury at gridgain.com. Okay, Alicia, over to you.
Hello. Okay, so first of all, I just wanted to let everyone know that Akmal is coming back on May 16th to do a deeper dive into machine and deep learning with Apache Ignite. So if that topic is of interest to you, I invite you to register for that. Even if you can't attend it live, you can register and we'll send you the recording and the slides. All right, so Akmal, this question was asked very early in your presentation. And
Yeah.
I think you covered it, but just to be sure, I'm going to go ahead and ask it for
Okay.
this person
Yes,
again.
sure.
Okay, so what do you mean by co-located processing? Can you explain that?
Okay. Yes. That's a great question, and thank you for asking. So, co-located processing. So, the idea is that in distributed systems, what we typically want to do is that if certain data is used together, it makes sense to store it together. So, think of the example I showed in the slides. You remember I showed you cities and countries. If I just go back here for a moment. So this particular, very similar to this kind of idea. So where we want to perform some operations, say upon a country where we've got all the cities located as well, we can do that. The fact is that we know where that data reside. We do not need to go and search across our cluster to find that data. And the ability to process that data on that node really can make a big difference. Because as you know, in distributed systems, the goal, and this is the same for Spark and Hadoop and other types of environments as well, it's better to try to locate data together that you want to process together. And that, again, saves having to shuffle a lot of data around your network. So you need to think carefully about how you're going to architect this. And of course, physically, there's only one way to do it. But if it makes sense, this can be a great advantage. So in this particular example, we see that cities are stored with country on a particular node, and they are co-located together. We can process them together as well. So if they are stored in different tables, for example, we can join these tables and they are stored on the same node. We don't have to search across our cluster, finding the data, and then potentially that causes a lot of performance problems as well, because moving data around is something we really want to avoid. I hope that was helpful and a bit clearer.
Okay, thank you. So the next question is, can you run Spark within the Ignite cluster as a service or such? I'd like to keep it simple and would like to have a single execution environment.
Oh, excellent question. I'll need to look into that one. I know there is a way that it's possible to run applications in a kind of embedded mode. I believe that's being deprecated, though. I think the preference is to try to run as separate processes. Let me just very briefly, let's have a look. On the actual Ignite documentation. There we go. So this embedded mode is being deprecated. Now that might not be the same thing as I think what the questioner is asking about, but you could certainly do it as a service. I've seen this being discussed recently, but it's something I'm very happy to dig deeper into and find out more. It's a great question, and I apologize I don't have a great answer, but excellent question. And this is why these webinars are great, because people always come up with these fabulous kind of real world type questions, it's kind of problems that they have in the trenches and really want solutions for. So I promise I will find out and be able to look that up. But feel free to drop me a direct email on that one.
Okay, so the person that asked that question, I will send you, just so you have it, Akmal's email address, and you guys can communicate directly.
Yeah.
All right, so we're about 2 minutes from the top of the hour. Are there any other questions for Akmal today? Let's see here. Just give it a second. And Akmal, while we're waiting, I want to thank you for a really good webinar. I think this topic is really important to a lot of people out there, and I appreciate everything that you're doing here. And audience, I hope that you enjoyed the show as well. So Akmal, thank you again for a great presentation.
Thank you very much, Alicia. And thank you to the attendees as well. Again, apologies, we couldn't finish earlier. But my boss tells me I talk too much, and I probably do. So this is why things went on a bit longer than I anticipated. And of course, with these when you're trying to do these live demos as well, you try to keep your fingers crossed that everything works okay, because, as they say, Murphy's Law, anything that can go wrong will go wrong at the worst possible time. So I'm very pleased that everything appeared to be okay, and we got the kind of results that we were looking for. But as I said, if you're interested in the code, or if there's anything further you'd like to follow up with, please feel free to drop me an email, and I'll do my very best to help you.
Okay, with that said, we'll end the webinar and we hope to see you on a future show. Thank you, everyone.
Thank you.